Welcome, everyone. Today, we're diving into an exciting new project titled Confidence-Gated Multi-Agent Debate for Relational Argument Mining. This research was developed by Jakub Baba and Yaroslav Chedsiak from the Warsaw University of Technology, and the presentation is dated October 2024. Let's jump right in. To start, we need to understand that argumentation is fundamentally relational at its core. Just looking at singular components or isolated statements isn't enough to properly map out a discourse. True argument mining requires what we call argument relation identification and classification, or ARIC. This means we have to simultaneously evaluate the logical dependencies between pairs of statements to determine if they support a claim, attack it, or have no relation at all. But here's the problem with using standard language models for this: the single-agent sycophancy loop. Relation classification requires deep reasoning about what connects two statements. However, single-agent LLMs often confidently assert logical links that are textually ungrounded. Even worse, when you prompt them to self-correct, they fall into a hallucination loop where they exhibit sycophantic self-reinforcement, essentially blindly agreeing with their own errors and validating their initial hallucinations. You might think traditional supervised models, like Roberta, would solve this, but they actually collapse on minority edge cases. These models rely heavily on annotated data. In datasets like the UKP corpus, the critical attack class is severely underrepresented, with only 160 instances compared to a massive majority of none relations. Because class-weighted training loss cannot compensate for this lack of raw examples, supervised models essentially blind themselves to counterarguments. So, let's compare three different approaches to relational argument mining. Supervised fine-tuning fails on rare classes, lacks interpretability, and has a high need for task-specific data. Single-agent prompting is a zero-shot approach but has low hallucination resistance. Our approach, gated multi-agent debate, wins out. It performs highly on rare classes, offers strong hallucination resistance, provides high interpretability through a debate transcript, and requires zero task-specific data. The only trade-off is a medium to high inference compute cost. How do we achieve this? By using dialectical interaction to break that self-reinforcement cycle. Instead of relying on flawed self-reflection, our framework replaces it with interagent discussion. We force agents into an adversarial arena, taking fixed, opposing positions as a proponent and an opponent over multiple rounds, all while being observed by a judge. This adversarial scrutiny is specifically designed to expose ungrounded reasoning and dismantle hallucinated logical links. However, there's a catch: the paradox of unconditional debate. Simply throwing more agentic intelligence at a problem does not yield better results if it's routed poorly. If you force agents to debate obvious truths, it acts like an overthinker, introducing noise and actually degrading predictions. Unconditional debate yields a near-zero net benefit. Therefore, multi-agent debate requires an architectural principle we call strategic friction, applying this friction exclusively to uncertain edge cases to clear the noise. This brings us to phase 1 of our framework, probabilistic initialization and the confidence gate. We use a manager agent to evaluate label probabilities. We set a confidence threshold, or tau, at 0.70. If the system is confident, it bypasses the debate for a direct label assignment. It restricts the debate to only the 14% of samples where the system is least certain. This single gate reduces total debate initializations by a massive 86%. Next is phase 2, the adversarial resolution engine. Inside the debate arena, the debate runs for 2 rounds, which equals 4 total turns, at a higher temperature of 0.7 to encourage diverse reasoning paths. Debater A acts as the proponent, tasked with pulling explicit textual evidence for a specific link. Debater B acts as the opponent. Crucially, forcing the opponent to systematically argue for the none position, the absence of any relation, provides a structural defense against generative hallucinations. Finally, we enter Phase 3, evidence-based adjudication. The full debate transcript is sent to a judge, powered by Gemini 2.5 Pro, running at a temperature of 0.0 for deterministic evaluation. The judge is explicitly instructed to penalize unsupported logical jumps. If neither debater provides sufficient textual grounding, the judge defaults to none, effectively trashing the discarded hallucinations and outputting only final, verified logical links. So, why did we choose a threshold of 0.70? This chart illustrates the diminishing returns beyond the certainty threshold. Our optimal gate is exactly at 0.70, which maximizes our macro F1 score. Pushing the threshold past this point triggers a huge explosion in computational cost, shown by the red area, while actively degrading the accuracy. The framework achieves maximum accuracy exactly when it applies the least necessary friction. Let's look at the final results. Generative reasoning completely circumvents the data trap. Even with access to the full training split, supervised models like RoBER to base and RoBER to large collapse on the rare attack class. In contrast, our gated multi-agent debate framework utilizes general linguistic knowledge to correctly identify nuanced contradictions. It achieves the highest F1 score of 0.427, requiring exactly 0 task-specific training examples. To wrap up, this research leaves us with 3 core architectural principles for agentic workflows. First, friction must be strategic. Debate only adds value when initial predictions are highly uncertain. Second, you must structure the adversarial dynamic by explicitly instructing an opponent to argue for the absence of a relation to beat hallucinations. And third, generative AI wins in low-resource environments, heavily outperforming supervised fine-tuning when class distributions are highly imbalanced. Thank you for watching.